Have you ever wondered how to build real-time streaming pipeline? Streaming data is everywhere nowadays. So if you look around, you will see lots of examples. For example, stock information, so stock exchange information, weather information, data coming from your watch, so health devices. All this information is coming fast and in big volumes, and they cannot be processed and analyzed using traditional batch processing techniques. This video continues video series dedicated to learning Microsoft Fabric. If you watched my past videos, we talked mostly about batching technology. So we created batching pipelines to bring the data from different sources. And then more recently, we learned using Spark transformation notebooks to change your data. The good news is that once you know Spark transformations, it's very easy to create streaming pipelines. Another good news is that streaming pipelines are not only required for building low latency, fast streaming pipelines, they can be also very useful to creating incremental logic for batch pipelines, because they allow you forget about complexities of building incremental logic. So everything will be taken care of by streaming technologies. Join me to learn more about that. Hi everyone, welcome to my channel. My name is Fikrat, and here's a quick preview of what I'm going to cover today. We'll start with the overview of structured streaming. So I'll explain what problems it's designed to solve. Then we'll have a quick discussion around Lambda architecture, which consists of batch and real-time workloads. Next, we're going to talk about internal mechanisms of streaming, structured streaming. So I'll explain how streaming works. Then we'll talk about streaming sources and the sinks, destination in Microsoft Fabric. Then we'll talk about different methods to write into the destinations, including append, complete, and update. Next, we're going to move to demo section, where I'll first explain how to ingest from file sources, whether it's from ADLS or Lakehouse, and write to the Lakehouse tables. I'll also explain how to manage streams, how to start, stop, read the status and the progress of the streams. Next, I'll show how to ingest from Azure Event Hub. Finally, we'll wrap up discussion with a few tips on how to monitor existing structured streaming, either from your Spark notebooks or from Spark UI. A quick reminder, if you are new to the channel, please subscribe so that you could always be up to date with my latest videos. Let me bring a quick overview of Spark structured streaming. Spark structured streaming has been designed to address needs of ingestion and processing of real-time big data sources, which requires low latency processing and analysis. So in today's world, there are lots of different sources that require quick reactions. Things like IoT devices or weather information or stock exchange information that needs to be analyzed within milliseconds, and in many cases requires some decision systems that needs to act on this data. So Spark structured streaming is a scalable and fault-tolerant streaming system. It's based on micro batches, so each macro batch could be up to 1 milliseconds. So by default, it's 500 milliseconds, but with the latest version of Spark, that latency can be as low as 1 millisecond. So as you can imagine, the main use case of structured streaming is building low latency real-time pipelines, workloads. But this technology is also good for batching workloads due to some intelligent incremental logic that's built in within this technology. Spark structured streaming delivers guarantees of your source data, source messages. There are a few guarantees options. The default one is called exactly once. It means that each of your message is guaranteed to deliver it, and there will be no duplicate. So if you have one message in the source, you will see one message in the target. Another guarantee method is called at least once. So it's more applicable for so-called continuous streaming, which is relatively new. It means that your messages will be delivered. However, there could be some duplicates in certain cases. As I mentioned earlier, Spark structured streaming employs fault-tolerant processing mechanism, and the way it does it using checkpoints logs. So these are the logs that are like watermarking based logs, and they ensure that if something happens in the middle of your stream resumes from wherever it's left. In terms of programming model, Spark structured streaming is very similar to batching APIs that we learned earlier. So if we'll talk about read and write APIs for structured streaming, and you will see that they resemble batching read and write APIs. Let's talk about Lambda architecture or Delta Lake. This is a diagram that I borrowed from Databricks websites. Here we see three main components of modern data warehousing architecture. So that's batch layer, which would contain your batch pipelines running on certain frequency, whether it's daily or hourly. And then some organization would also have speed layer, which would consist of real-time pipelines, which require low latency processing. And finally, you have a server layer, which will be your dashboard reporting, connecting to your data and consuming it. So let's talk about internals of structured streaming. This is another diagram that I borrowed from Databricks. It represents timeline with 1 second interval here at the top. As I mentioned, structured streaming is micro-batch based technology. And each second, so it shows your data in the source at certain points. So here, this yellow boxes represents your data. Let's say at the second one, you have this data. So that data is being picked up and put in is a middle layer called result. So that's area in the memory that's managed by structured streaming, and it immediately delivered to the output. So whether it's your lakehouse or some other destination. And then next second, your data grows. So let's say you have new rows. That increment is also delivered to this mid layer and then being passed to output. And so on and so forth. As your data grows, newly added rows are being read from source and delivered to the output. And the Spark streaming has a very good mechanism to understand what's new in your source. Let's talk about source and the destinations for Spark streaming in Microsoft Fabric. Spark streaming can read from various file sources like Azure Data Lake storage, Gen 2 or AWS S3 storage or Lakehouse. It can also read from Lakehouse Delta Lake tables that are part of your OneLake hub. And then it can read from Event Hub, Azure Event Hub. There are few other data sources that are mostly for testing and development purposes. So that includes socket source, which is basically console, which allows you to read words that you type in the console. And then there is a rate source, which allows you to generate random information. Again, this is also for testing purposes. So in terms of destinations, streaming can write into Lakehouse Delta Lake tables. That's probably the most common use case. And then it can write into Event Hub and the Kafka. Finally, it can also write for console or memory. Again, this is for debugging purposes. So let's talk about write methods to destinations. When you write the data in Spark structure streaming, you have to specify write mode. So that can be one of the three methods. So you can either use append, which will be default, so it will be used even if you don't specify any mode. So that assumes that your data, source data, is not being changed, so all you have is just new rows. Then there is a complete mode, which assumes that your data that you are writing to the destination is much smaller than your source data. So this is best suited for aggregations. And then there is update method, which allows you to transfer your data updated in the source. However, it's not available for all destinations. So to give you an example, update is you cannot use update method for Lakehouse tables. All right, it's demo time. As a first demo, I'm gonna show how to create streaming job, which will read from files, source files, and write into the Lakehouse. So I am in Microsoft Fabric, and I have opened the bronze Lakehouse that we have been working in the previous videos. If you don't have that Lakehouse, so go ahead and create an empty Lakehouse. And under that, I have created this folder structures under unmanaged files section. So basically I have created landing folder, and under that I created Parquet and the sales subfolder. So my intention is to bring data, some files here on the sales folder, and then my streaming will read from this folder. So let me show you pipelines that I have created for that purpose. So this is a very simple data pipeline. If you don't know how to create data pipelines, please take a look at few videos I have posted in this channel. For now, I'll just assume that you know the fundamentals of data pipeline, and I'll explain how I created this. So I added copy activity, simple copy activity here. Let me show its source. The source is sample data set. If I click on browse button, so this is a database, so it's called retail data for wide vault importers database. So that's open source play database. And within that, I have selected fact sale table. So this is large table. It has around 50 million rows. Okay, I'll just cancel this. So this is my source, and I'm gonna open destination. So my destination is Lakehouse. I selected bronze Lakehouse, and within that I have selected files. So that means that my data will go to unmanaged section of this Lakehouse, and here I say it should go to this subfolder, so this path, and they will have the same names as they have in the source. So I didn't specify names. File format is Parquet. It's default source files format, and under advanced I have changed few things. So I say use preserve hierarchy as copy behavior because I want my target structure resemble my source folder structure. And I made little change here. I say maximum rows per file is going to be 1 million row. I did that because I want this pipeline to run sometime so that I could show you how streaming works. Otherwise, this pipeline may finish very fast. Okay, now let me go back to my notebook and walk you through the first few cells. So my first cell reads data using read API. So this is something that we have talked about in the past videos. So you don't have to run this. I run this, that was a little trick, so that I could get schema of this file without actually typing this. So I just read this and I used df schema method, which gave me that schema, and you can see it's exported here nicely. And then all I did is just copy that schema here, and I assigned it to variable. And of course I needed to add this library so that I could assign this. So let me run this. Okay, so my next cell is optional. It cleans up the checkpoint folder which may be left over from previous runs. So I mentioned that for structure streaming you have to specify checkpoint folder, and when you run your streaming at least once, that this folder will be filled. And if you run it next time, streaming will not do anything because logs will remember your previous state. And for that reason, if you have to run this notebook multiple times, you have to come here and run this command so that it would clean this folder. So MS Spark utilities are a good way to remove folders automatically. So that's what this command does. Okay, I'm gonna run this. So my checkpoints folder is going to be also on the files section. I created checkpoints folder. So under that I have, let me check if I have this sales folder. No, actually I don't have it, so I don't need to run this. Finally, this is also house cleaning task, so you may need it if you run it repeatedly. So I have run this earlier, so I'm going to run it so that we had a clean start. Okay, so while this is running, let me show you a streaming command. So that's the core of this notebook. What I am doing here, so I'm using read stream APIs here, which is very similar to read API that we use to create batching data frames in the past videos. And from there I specify schema of the files. That's where this sales schema variable comes into play. And then I use, so this is optional parameter. So this parameters tells ingest only one file at a time. If you skip that, if you don't specify that, streaming will read all the files available. There is certain limit, of course, but it may ingest multiple files in parallel. which I want to avoid just so that you could see how this streaming works. So I want this streaming to work sequentially in this case. That's why I have specified this. But you can comment that if you are looking for fast execution of streaming. The next command specifies path for the streaming. So this is a command. So I'm saying the file format is Parquet, and I specify path for that. So as I mentioned, I'm expecting files in this folder. So under sales folder, under the landing, and then the next few commands are really just adding small light transformation to that, so like ingestion timelines and source file names, so that we could track injection progress. So basically the first command, so to summarize, the first command reads data into data frame using read stream API. So it wouldn't do anything unless you run the second command, which I'm going to describe now. So my next command is using write stream API from this data frame. So this is here. And then I have optional method here called query name. It will ensure that your streaming has names, so that makes it easy to track. So if you have multiple streams, you can easily see which streams is doing what. Again, this is optional, and then the next method here, so output mode, tells what is going to be destination write mode. So as I mentioned, there are a few modes. Its default is append, so you can skip this, and by default it will be append. But there are a few cases that that you may want to use different output modes, which I will be talking in a little bit later. Okay, so next few formats specify a format of the data. So it's gonna be delta because I'm writing into Lakehouse table, delta tables, and then these two commands are critical. So this option, you may specify multiple options with this command. So as a first option, I am specifying path, so destination path. So destination path is going to come from variable. So this is my variable here, and the variable is basically going to say table name under the tables folder. So basically this is to tell that write it is under table folder, and here is my subfolder's name. So this is sales folder. So this is my path, option path. And then this option tells location of your checkpoints. So as I mentioned earlier, checkpoints are mandatory. You have to specify checkpoints for streaming. It will ensure that your streaming have logs and it will know, so that it will use these logs to manage stream as well as in case for fault tolerance. So if your stream happens to break in the middle, it will use these logs to resume from where it's left over. Okay, so let me run these two commands. So you will not see results. So my write streams result, API result, is assigned to a query. So this is something I'll use to manage the streaming. So let me show that part. So this is a command that allows you to start stream. So my stream has not started yet. So this is a time where I can start the stream using start method, and I will use queries method. So basically I assigned here query, my data frame to query, and here I am using start to basically to start that stream. And the results is assigned to variable which is going to serve us a streaming handle. So streaming handle is good, so you can use that to stop the stream, as well as you can see, it will allow you to see the status of the stream, which I'm gonna show shortly. So let me run this. Okay, so it wouldn't produce anything, and here is some very useful commands to show your streaming status. So here I am using that streaming handle, and I use its property called isActive to understand whether my streaming is running or not, so whether it's active or not. And here I have another expression, another property, which shows status of my stream. So my next command shows another useful property called last progress. So let me run this, and it will be easier to understand. Okay, so let's see what we have got here. So my stream's status says it's active, so it's here. So my stream is running, and when I look to streaming status, it shows getting offset. So it's not doing anything yet because my source folder is empty. And if I look to the progress, so this is a section which contains all the progress information. So it has lots of useful information, but for now it does not show anything useful because for now it's empty. Stream didn't start ingesting yet. So while the stream is running, so let me go to my data pipeline and start it. Okay, so my pipeline is running, so let me go back and see if we've got anything in that folder. So I'm gonna go here and refresh it. Expand this. Yeah, we got first few files. So now I can come here and rerun these commands to see what's the status of my streaming. So for now it's still waiting for data to arrive. So streaming job will come back to the source folder from time to time, and whenever it sees the files, it will start ingestion. So it's not aware that the folder has some files yet. So let me keep running this few times. Okay, now I see a new status. So if you look here, so my new status says processing new data. So that means that the stream is actively doing ingestion. And if I'll take a look at last progress, now I see some actual numbers. So some useful properties here. So this is basically dictionary. So some useful information here is my stream's name. So again, I assign this name using query name method, and I have timestamp. So each batch, so as I mentioned earlier, streaming is nothing but a series of micro batch. So each batch has its number and timestamp. So this is a timestamp that shows the last batch timestamp. So this is my batch ID. So as I run it multiple times, you will see this batch ID increasing. This is number of input rows in the source. Because I limited number of rows to 1 million in each file inside my data pipeline. So this is what it shows. And here, input rows per second. So how many rows streaming receives as a part of this batch, and how many rows it processed. So how many rows is processed is here. How many rows processed? So sorry, this is just rate. So you can see it's processed per second. And input rows per second is also rate per second. And you can also see some other useful information like duration of this batch, which could be helpful for performance troubleshooting of the streaming. Okay, so basically this payload has been produced by last progress method or attribute. Now I'm gonna go further and show you another useful command to monitor your streaming, which is called recent progress. So if I run this, you will see multiple recent progress statuses. So if I scroll up, now you can see we have batch ID 0 with input row 0, and if we take a look further, you have some other batches. So let me find some other batches here. It's a little bit messy, and I'll show you how to bring it and show it as a nice data frame little later. Okay, let me scroll down and navigate to the next cell. So my next cell is also helpful from monitoring status of your all streams. So this command will give you list of your active streams, and once you have it, you can build some iterative logic like this. So for loop, where you just go over each stream and print its name. So let me run this and see what are my active streams. So I can see that we have only one cell stream. Okay, now I can go and check my data. So let me run this script. So basically, I have aggregate script which groups by source file name. So remember, this is a field that I added during ingestion using a metadata function. So if I run this, so this is my data. So I have got file names, and each file has 1 million as expected. Okay, so let me scroll down and navigate to the next cell, which takes data produced by recent progress attribute that I showed earlier and converts into JSON and converts it then to data frame to show it in a nice format. So let me show it here. So basically I am using JSON dumps here to read recent progress feature attribute from my stream, and then I convert it to data frame using JSON APIs, which we learned earlier. So the next is just making it more easy to read. So run this. So here I have selected only few attributes which I think is most useful when monitoring your stream progress. So that's number of input rows, that is usually unchanged, and then inputs per input rows per second, which rows as speed at which your rows become available for your micro batch, and then rows per second, process rows per second. That represents how many rows out of this have been processed. And of course, you will see batch ID here. So once you have that, of course, you can show it in nice charts. So with a few clicks, you can include like more, so you can create a visually appealing charts. So in this case, I am showing input rows per second and rows per processed by per second, and I can select average here, and if I click apply, so I can see the trend. So you can come back to this cell and run it multiple times during your stream ingestion just to see how your streaming is doing. So that's a little trick. There are some other ways of monitoring stream I will describe at the end of this demo. Okay, so my stream is doing well. If I wait until end, so it will process all the files and then will keep waiting until this either my cluster is shut down or I stop the stream manually. So let me show that command as well. So this is how you can do. So basically, if I comment this and uncomment that, so using your stream handle, you can stop your stream. And if I check my list of my active streams, I won't see anything in the output. You can stop the stream here as well if you are looking to stop all your streams at once. So this is another easy method. Okay, now that we learned how to ingest, how to create streaming pipelines to ingest from source files and how to manage active streams, let's see how we can ingest from Event Hubs, which is another popular platform for handling real-time data streams. So if I scroll down, my next command installs Python libraries necessary to interact with Azure Event Hubs. And then my next command is just using that library to import this function, and then I'm using few variables to assign connection string, which I'm going to explain shortly. Then I use this configuration setting, which is pretty standard, so you just can run it. So basically, we will take your connection string, bring it here, copy paste, and then you will need to run this cell. So let me navigate to my Event Hub, and if I navigate to shared access policies, for the purpose of ingestion, all I need is listen permissions. So you can go ahead and create new policy, and from there, so let me just show it here, you have to specify permissions. So again, listen permission is all that you need. So once you created that, you will see dialogs box with a few important configuration settings. From there, you'll need to copy connection string. So that's all you needed. And come back to this notebook and paste it here. And once you run it, then you just navigate to the next cell. So my next cell simply removes checkpointing folder. So if you have to run it multiple times, you need to run, otherwise you can skip that. And so this is a cell where I am creating that stream. So this is very similar to file source stream I showed earlier. The difference is that I use this format method where I say my format is going to be Event Hubs, and then I also specify option which tells which brings that configuration variables that I created earlier, and I finally load. So this is reading part of my streaming API. So result is assigned to data frame, and then next I'm gonna use write stream API to write into the Lakehouse. So just like before, I apply some light transformations. One thing is important to know when you're ingesting from Event Hub is that payload, actual messaging payload, comes as a binary. So you have to convert it to string. So that's what this next command does. So I'm using cast to convert it to string, and the column that you need to convert is called body. So regardless of what are your topics in your Event Hub, so it's always your payload comes as a body, as a field with the name of body, and you convert it to string. So the next commands are really straightforward. So I specify delta format as a destination format, checkpoint location, and output mode, and of course I have to specify path where I am writing this data. So let me run this, and then just like with previous case, I can use start method to assign the result to handle, streaming handle, and then I'll use that streaming handle to inquire my stream's status. So active status, right now it's waiting, there's nothing in my Event Hub, but let me go back to my Event Hub and produce some sample data. So I can use generate data feature, which is very handy to test your interaction with Event Hubs. So from here, I can come here. There is various data sets here. I'm gonna use stock data, which brings stock information like that. This is JSON format, so payload is JSON format. And I'll say generate 100 events for me. So each event has multiple records here, and I'm going to generate 100 events here. Okay, now that I have that running, so let me go back to my notebook and run this command. Actually, I don't need to start it anymore because my streaming is already running. So let me copy this to the next cell. And I'll just need to run this cell from time to time to see if I am receiving any data. Okay, so my streaming has started processing data. Now I can see some useful information here. So number of rows per second. So the data is likely to be written to the destination table. Let me check my data here. My converted field's name is body as a string. So this is a converted column, body as a string. And now I can take this field and parse it to get some subfields. So this is one way of processing. I created schema here. I can use this. So basically this schema repeats the schema of the JSON for that particular data. So if I just run this, and then I can use from JSON method that I described in one of my past videos to extract certain parts of this JSON information. So let me run this. Okay, so I can get, I can see volume, symbol, and some other information. Okay, so to summarize, we have looked into how to create streaming pipelines from file sources and event hubs. Now, before wrap up, let me demonstrate another way of monitoring your streaming streams. So you can do it by navigating to Monitoring Hub. And from here, so this is a notebook that is still running, so you can open that. And then from here, you can go to Spark UI. In Spark UI, you will find Structured Streaming tab. If you navigate to that, it will show you status of your streaming query. So you can see that one is still running, and you can see other streams that have completed recently. So you can see duration of them, all this useful information about how many rows have been processed, so rate of processing, input as well. So it's lots of good information. Okay, so that concludes today's discussion. To recap, we learned how to create simple streaming pipelines to read from file source and event hubs and write into Lakehouse tables, so Lakehouse Delta tables. We also learned basic management techniques for streaming, so basically start, stop, inquire status, and see track the progress of the stream. In the next video, we're going to explore different trigger types that are available with Spark Streaming within Microsoft Fabric. We're going to build pipelines that will stream data between Lakehouse tables. I hope you find it helpful. Thanks for watching, and I hope you see it in future videos.